Welcome to this electrical engineering knowledge sharing channel AC Power System presented by Alan Paul. We are discussing workshop 8 under which we will be discussing the various parts of the control scheme of medium voltage and high voltage switchgear. Of this workshop 8, today is the second session 2, where we will be discussing about the closing schematics or closing circuit details of medium voltage and high voltage switchgear. In session 1, we have given the highlights of the power circuit of the switchgear as well as the various parts of the control schematics of the medium and high voltage switchgear which are required to complete the control schematics. So of that various parts which are discussed as 8 parts, of that the first part, that is the closing schematics or closing scheme or closing circuit, we are going to discuss today. To save the time, I have already drawn the schematics on the board on which we will be discussing the control closing circuits. For just to recall the previous discussion, that means session 1 discussion of workshop 8, where we have discussed about the busbar arrangement and the breaker and the other power device required for the switchgear. We have seen that in case of circuit breaker in the fixed type design, we need an isolator on the bus side. That means if this is the bus bar, and if then there will be isolator on the input side which have a provision for earthing, then we have the circuit breaker. So this is your circuit breaker CB, and then it is going to the further downward to the power to the other nodes. So in this case, this is one of the power device whose interlock is required in the circuit breaker. This power device is called disconnector switch oblique arc switch. It has a both provision. It can use as a disconnector as well as arc switch. This is already discussed in session 1 discussion. And when the disconnector is not there, in that case the circuit breaker is a withdrawal type, where it has a 3 position: connected, test position and the disconnected position. So now we have considered this type of arrangement. If this is not there, then the circuit breaker disconnected position or the test position or the connected position shall be taken into consideration instead of the arc switch position. So this is one of the points we need to we have already discussed. Just to highlight, I have shown this thing why this interlock is required. So whatever the interlock required in the closing circuit with the disconnector will be discussing over here. So we have already seen that to operate this overall closing scheme, we need the auxiliary power supply. So that auxiliary means it is the auxiliary control power supply. It could be DC or it could be AC. So we have considered DC power supply. This is a positive and this is your negative. Suppose it is a 120 volt supply, 120 volt DC. So this is a positive and this is a negative 120 volt. The bus is running. Now from the supply this is a MCB. This is a MCB which is controlling the supply. So this MCB is always present there. Normally for each circuit we use one separate MCB. Like a closing circuit 1 MCB, tripping circuit 1 MCB, and this MCB auxiliary contact we use for the indication purpose at the remote. This MCB is not a simple MCB. This MCB has a short circuit protection, overload protection, as well as it has auxiliary contact. That auxiliary contact we will use for the status of the MCB, because that is a very vital supply. If this supply is off, then you cannot do anything. So continuous monitoring of this supply is essential, and that monitoring we do using the auxiliary contact of this MCB to the indication panel or in the remote. So the auxiliary contact of this MCB we use for the indication purpose or alarm purpose. If this MCB trip, that means the power supply is off, immediately we get alarm. Then we will take the necessary action. So this is MCB. Then this closing of the circuit breaker, we have to see here. This closing we generally differ as a local and remote. Local means from the switchgear panel itself. If the switchgear is indoor switchgear, or if it is outdoor switchgear, is still the control panel of the switchgear located indoor. So this local means on the control panel or on the switchgear panel. That is the local position. Except this position, if there is any other position from where this switchgear is getting controlled, This switchgear means this particular feeder panel or the general incomer panel but any one of the panel is getting controlled from the remote, then that position will be called the remote position. Now the remote could be different positions. It could be control room, it could be another control room, it could be from the process area, it could be from the remote receiving station, it could be different. Any other except the local position means switchgear position. If this switchgear or feeder is controlled from any other different places, all these different places are called the remote locations. So it could be multiple location, it could be control room, it could be DCS instrumentation room, it could be process area, it could be far remote receiving station. It could happen like that. And so the fiber the signal will be coming. So these are all the remote positions. So those remote position I have shown over here. You see, we have a local remote selector switch over here. After the power supply coming, first job I have to decide I want to control the switchgear from the local or from remote. That is the first option. First selection. So this is the selector switch. We call it a local remote selector switch. It is a selector switch. Local, it has a two position, local and remote. Local position means from the switchgear panel we are going to control this breaker. Means we are going to close the breaker. So in the local, when you put this switch in the local position, then this contact will come over here. So it will get through this. Then it will come over here. Now here is the interlock. Before closing the circuit breaker, I need to understand whether the disconnector switch, suppose this is a circuit breaker coil. Before closing this coil, I have to understand whether the isolator is on or off. Now this isolator, now here is a glimpse. Now what is that? Now when I am going to close the switchgear from the locally, mainly in two occasions we close the breaker from locally. One position, what? If there is a breaker problem, we need to test the breaker. So during testing of the breaker, what we do, we keep the isolator open or we take the breaker in the test position. So breaker is not in service position. So in case of fixed type design, when the isolator is there, we take the isolator disconnected position, means isolator is off. Isolator off position we take when we want to test the circuit breaker. During testing of the circuit breaker, we keep the power circuit off. How can we do the power circuit off? We switch off the isolator, so the power is not coming, and then we go to the closing. We test the closing circuit or closing coil of the breaker, whether the breaker is getting closed or not. That is one occasion. Another occasion, due to some remote problem, maybe the breaker is not able to close from the remote, and during operation we need to close the breaker. In that case, we will come to the local panel and we will close the breaker. In that case, breaker will be in service position, means breaker is this isolator is closed. So whether the isolator is open or isolator is closed, in both cases, this breaker need to close from the local. So local, when we go for the local connection of the breaker, local closing of the breaker, this isolator two position is working. One position is the isolator is off or disconnector switch is off. In that position we need to close the breaker, that is for the testing purpose. Another for emergency operation, when the remote operation is failed or due to some reason, then we need to close the breaker locally. In that case, this isolator will be one position. And if we go to the drop type breaker, so this closing position means breaker is in service position. So service position contact in one path. Similarly, if the breaker is a test position, then also we want to close the breaker. So off position means service breaker test position is another contact. So that is we have shown over here. This is in the local position. We are using, this is the isolator contact. The isolator has a three contact. This is, you see, this is on, off, earth. This is a, I have written over here, on, off, earth. Means from the left side, first is, this is on position. This is the off position and this is the earth position. But when we are talking the disconnector, then the earth position has no meaning. It is only on position and off position. Similarly, this is interlock with the second set of contact. Here also this is on position, this is off and this is earth position, and these two are common position, you can say. So now you see when we are going to do the test, in that case we will be using this position. Means isolator is off position. This is off position. You see this center is off, means center, this is off position. This disconnect, this switch, this contact will be coming over here. So off position it is getting through. When we are going to real closing the breaker, then we will be using this contact. At that time, when the isolator is closed position, immediately this is on position. You see, this is on means isolator is closed. Then this contact will come over here. So this path is also through. So in both cases, whether the isolator is off or isolator is on, or in the case of drop type breaker, where the breaker is connected position, this is a connected position, or breaker in test position. In both cases, this operation, this logic is maintained either through this path and this path. So this is the isolator interlock in the closing circuit. So before closing the breaker, I need to understand, I have to make sure isolator interlock is satisfied, or isolator interlock is made, that is why I am doing through this. So this is isolator interlock. Then what I want to go, I want to, this from the local position I am going to close the breaker. So on the switchgear local panel, there is a switch. This is a manual switch, we call it a breaker control switch, BCS, breaker control switch. That breaker control switch is a 3 position, off, on, off, neutral and close position. Means another way you can say, it is a off, this is a trip is open, or you can say open, this is a neutral position, nothing will happen, and this is on position or close position. We call a strip neutral close switch or breaker control switch. This switch can be used for closing purpose as well as breaker opening purpose. So here we are going to close the breaker. So first, then what we will do, we will put the switch in the close position. So this is the close means on the right hand side corner. You see there are 3. This is the left, it is the center, it is the extreme right. So it has a 3 position. So 3 position. This is the my close position. So this switch will turn over here. Then it will be, when I rotate the switch in the close position, this contact will make. So breaker is in the remote, the switch, local remote switch in the local position. In the local position, I am going to close the breaker. So I put the switch in close position. At that time, I am making sure the breaker is in the right condition. Either breaker is, isolator is in the right position, means either isolator is off or isolator is on. Isolator is off position will be used for the testing purpose of the closing circuit, and isolator on position will be using for real powering of the circuit. So this is the local path, then it is going over here, then after coming over, this is a common path, then it is there is a permission. When I am going to testing the breaker, at that time power circuit is off, so I do not need any other permission, I can go direct closing. So that's why when it is for testing purpose, the path will be, this is for the local, then breaker I am going to close, and this is represent the test position. You see it is off position. Isolated off position means in case of drought it is a test position. Through the test position it is going direct over here. It is coming in this position. Then again I have put a second set of this is actually earth switch contact. In this earth switch contact, if the earth switch is, you see this is the on position and this is the off position, and this is the earth position. The on and off means this is actually earth switch is off. Earth switch is not closed, means this connector is off position. So this is the off position, it goes through this, then it is going over here. Then again it is a disconnector switch. Disconnector switch also it is a off position. You see it is off position. Then it will come over here and then going to the closing. This is a closing coil. So breaker is getting closed. These 2 buttons I am discussing afterwards. So in the local path, when we want to test the breaker, it will go through this way, and all over the way it is getting closing. But when I am going to, okay, let me discuss another 2 points. In this path, this is another interlock, when I am going to close the breaker, I have to make sure, this circuit breaker closing coil and trip coil, it has a spring. There is a power spring which is remain charged. So if this spring is not charged, I cannot close the breaker, because in that the breaker will not trip. If there is a fall, spring is discharged, then after closing the breaker will not able to trip the breaker. When you open the trip button, breaker will not close because spring has no energy. So I have to make sure before closing the breaker, spring is charged fully and it has enough energy to open one requirement. So that interlock is required. That interlock we get from the disconnector switch. There is a small device which has a microprocessor or which is the intelligent device. That intelligent device can give a contact, and that contact is NC contact. The NC contact means system is okay. This spring charging system, closing circuit, tripping spring is fully energized, and you can close the breaker. That interlock is incorporated over here. If this contact is open, means spring is not fully charged, or there is a problem with the tripping circuit, or there is an issue with the mechanism. in that case we will not able to close the breaker, because when there is a problem with the mechanism of the disconnector or this closing coil, tripping coil mechanism, immediately it will open, so power will not flow. So this contact in C, it is a closed, means system is healthy, means tripping system is healthy, I can close the breaker. So this is the interlock, and this is the emergency push button. For any unfortunate reason, suppose this mechanism is not operating, or there is a problem with the tripping coil, or there is a problem, so you in that case will not allow to close the breaker. So what we do, we use the emergency push button. It is a lock type push button. So if you press the push button, immediately this will open, and you will not able to close the breaker. If there is an emergency system, in that case we press the emergency push button and lock it so that nobody can close the breaker till the job is completed. So these two interlock also incorporated in the closing circuit. So this is for the local closing for testing purpose. Okay. Now, in addition to the local closing, we need to close the circuit breaker from the remote. So if we want to close the circuit breaker from the remote, I have already said remote could be different locations, not only one location. It could be control room, it could be instrumentation control room, it could be electrical control room, it could be process area, it could be remote receiving station which may be few hundred kilometers away. That is also possible through the fiber optic cable. So all these positions are the remote position. From all the remote position also we are able to close the breaker. So these are the various closing command we can give from here. So these are the command we are giving. So if we want to close, suppose this command is from the DCS, from the digital it is a instrument control or DCS system. If we want to close the breaker, then from the DCS we issue this closing command. This will close, immediately it will come over here. Now here is a question, when I am doing from the local, I can see the breaker and all these things, but when I am doing from the remote, I am not able to see the switchgear internal all arrangement. So I have to make sure before closing from the remote, system is perfectly healthy and there is no abnormal condition of the system. Once that is ensured, then and all the remote interlock are present, then only I can close the breaker from the remote. From the remote closing, we need to be more vigilant, because when I am doing from the remote, from the local, on the switchgear panel, all the protection relays are there, all the interlocks are there, all the healthy indications are there. I can see everything on the panel. Relay is healthy, indication light is healthy, breaker, close partition, everything is there. So I can close locally by observing all these things. But when I am remote, I am not near to the switchgear, I am not aware on the switchgear panel what is the condition. So in that case, remotely, through the intelligence, I have to make sure everything is alright. That means, when I am closing the breaker from the remote, I need to know that entire closing and tripping circuit is healthy, breaker is ready to trip. If we close it, if there is any abnormal condition in the system, immediately breaker will trip upon closing. That interlock is there. All the protection relays are not operating. That is also we have to make sure. If the protection relay are operated already, I will not able to close the breaker. That interlock should be present. Otherwise, protection relay operated means there is a fault in the system. On that fault condition, I am closing the breaker. That is not right. So I have to keep that provision. Then I have to see there is a breaker trip coil. Now for medium voltage switchgear, sometimes there is a two trip coil. Trip coil 1, trip coil 2. Normally in the medium 3.3 kV, 6.6 kV, we have only one trip coil. But for 11 kV, 15 kV, 22 kV, 33 kV, sometimes we have a two trip coil. So I have to check both the trip coil is healthy. So you know the trip coil healthy condition, we monitor through a trip coil supervision relay. So that supervision relay gives some auxiliary contact. If any of the supervision relay is failed, but the trip coil is not healthy, then the supervision relay will be energized. Normally this supervision relay is always energized. The moment trip circuit has some fault, the relay will drop out, that means the contact will get open. So that is another monitoring is required when I am doing the remote. But when I am locally, the trip coil supervision relay is on the panel, I can see the relay is healthy or not. But when I am remote, I am not able to see this, that interlock is required. That means when I am closing the breaker from the remote, what I need to see, I have to get a permission from the system, various parts of the system, to ensure all the parts are healthy condition, and if I close the breaker and if there is any sudden abnormal condition comes in, breaker is adequate or breaker has enough strength to trip. That I have to make sure. That's why we need another permissive circuit to close the breaker. This is the permissive, closing permissive is coming over here. This closing permissive is actually one relay. The relay contact we have used over here. That is when I am putting the breaker in the remote position. You see here, it is the remote position. When I am putting the breaker in the remote position, either this position, any of the remote position, I am closing the breaker. It will come over here. Then I have a close permissive over here. This is the close permissive. This close permissive high I am getting, that is I am coming afterwards. On the close permissive is there, then only breaker actual energization will be possible. It will come over here. Then from here again this arc switch interlock. This is a disconnector switch interlock. It will come. Then this is a spring charging mechanism interlock. This is the emergency push button. Then it is closing the coil. So when I am going to remote closing or the local closing on actual energization, I need this close permissive. Without close permissive, I am not able to close the breaker. So this close permissive, how it is coming? What I said, close permissive is coming from the various interlock in the closing circuit. What is the interlock? First we said I have to make sure that there is no abnormal condition in the circuit. In the power circuit, there is an abnormal condition, means there is no fault in the power circuit. So how we distinguish the fault? If there is a fault in the system, immediately protection relay is operating. Now this protection relay, when it is operating, protection relay contact we do not directly wire in the closing circuit. We use another lockout relay. We call it protection lockout relay. This lockout relay for any particular protection, now a numerical relay, there is multiple protection functions are there. Now depending on the requirement, we group this protection function, maybe 2 groups or 3 groups. One group we give in one lockout relay, second group of protection we give another lockout relay, third group of protection we give another lockout relay. Or sometimes we may divide into 2 groups. Sometimes we do not do the grouping, all the protection functions put on one lockout relay. So depending on the protection functions, how many protection functions are there, how much important those protection functions, based on that this protection function can be grouped in a couple of 2 or 3 or 1. It may be 1, it may be 2 group, it may be 3 group. Each groups are activated once that particular group protection functions are operating in the numerical relay. The output of the numerical relay is going to activate one lockout relay. That lockout relay, what is the difference? Normally numerical relay output contact is not highly current rated. It cannot carry the closing coil current or tripping coil current. It is a high rated current, about 10 ampere or 15 ampere rating. But that's why we use a separate lockout relay whose output contact is high current rating. That lockout relay is getting activated. So if I have considered here 3 lockout relay, so maybe all the protection function in a numerical relay is grouped into 3. It has a 3 output contact. First output contact for one lockout relay, that will be 861. 86 we call it lockout relay, but I am using 3 lockout relay. I am using 861 number. This may be one group of protection functions. Then 862 another group of protection functions, and this is 863 another group of protection function. It could be only 2, it could be only 1. So I have to make sure before closing that none of the protection relay has operated, means none of the lockout relay has operated. Lockout relay are de-energized condition, means there is no fault on the protection on the system. So you see this is this is NC position, means relay has not operating. If the relay is operating, immediately it will go over here. So relay is not operating, means NC condition means relay, this group of protection function has not operated. That means that function, that type of fault condition is not existing in the circuit. Then the second lockout relay also it is NC contact, it is not operating. Then third set of contact is also not operating. If any of the group of protection operate, immediately this contact come over here. You see, then immediately the circuit is open. The power cannot flow through this. That means you cannot close the breaker. You cannot. In that case, if any of the contact is open, then what will happen? This permissive relay. This is a closing permissive relay. Which I have used the contact over here. The relay coil is here. How this relay coil is activating? Through the lockout relay. Any of the lockout relay is operating, it will not operate. If the none of the operating lockout relay is operating, then only this power will come from here up to this point. It is called 96 relay. So there are two tip coil. I have considered this switchgear has a two tip coil. So tip coil 1 and tip coil 2, and both the tip coil, you see, normally the tip coil supervision, it is a normally energized relay. It is normally always energized. Energized means this contact, it is normally NC contact, but it becomes this one when the tip coil is filled, then immediately it becomes NC. But when it becomes NC, now normally this contact is NO, means this tip coil is normally energized, means normally energized condition, this contact will come over here. That means tip coil is helping with this contact switch over here, so this path will be through it. And when this tip coil fail, immediately it become open. So this contact is normally NC contact. When the power supply is going, this contact is even relay is energized, means NO contact come to NC contact, so it will be NC position. So both switch will be coming in the NC position. From the NO it come to the normally closed position, and it will give a power. And this position is another interlock we are using in the closing permissive. This interlock is for this feeder. What I have shown over here, this feeder is going to some substation. So in the substation, before closing this breaker, I have to make sure what is the condition over here. Here might be there is this supply will go for some, suppose this supply is going to another switch here, where already there is a power supply. There is a power supply coming from some other source, and this feeder is coming connected over here. So before closing this breaker, I have to make sure whether this switchboard is already powered or it is not powered. If this is a powered, then I need to synchronize this power. So there is a 25 relay over here between these two. If this 25 relay give permissive, then only I can close the breaker. Otherwise I cannot close the breaker, because in that case it will be asynchronous closing, and this immediately it will trip or there will be a fire. So I have to make sure this 25 relay is giving permissive. That permissive I have taken over here. Sometimes there will be another permissive. Maybe there is an isolator over here with arc position. Before closing the switch, I have to make sure the remote and isolator is not arc, and the switch isolator is on position, and the synchronizing is there. In that case, isolator arc position contact and synchronizing relay contact both should be used over here to make sure that the remote is ready to receive the power. So this is another interlock. When both the interlock met, and if there is any other interlock is required, and there is another interlock over here, in addition to this, suppose the switchgear I am going to close, I have put the isolator on, but I have not removed the handle. You know, the isolator fixed type switchgear, this isolator open close I can do by motorized, and also I can do manually. There is a rod, I will insert the rod inside, then I will rotate it on the respective position. So I have to make sure, and as well as it can be operated to the motor as well. Electrically and manually both the switch can be operating. So when I am closing the breaker, I have to make sure the operating handle has not inserted inside the switch gear. If I insert the switch gear, then there is a possibility of the switch can be moved to the arc position, then there will be a fault condition. So this is another interlock which makes sure the operating handle is not inserted. If the operating handle this is normally NC, the moment I insert the operating handle, it becomes NO, and it will not flow the power. So the closing permissive relay will not pick up. So this is also make sure the operating handle is not in position. With this three interlock, we will get the close permissive. Then that means the lockout relay not operating means there is no fault in the circuit. Both the tip coil or single tip coil, whatever their combination, both the tip coil and this associated circuit are healthy condition. This is ready to trip. Downstream interlock means downstream disconnected. If there is the disconnected is not arc, it is a one position. And if there is a synchronizing provision, the synchronizing relay giving the permissive and the local arc switch, I am not going to operate. When all this condition is met, then there is a CP. This is auxiliary relay. It is a closing permissive relay. This relay will pick up. This relay has a lot of auxiliary contact. NO, NC, various contact is there. So any one of the contact I am using over here, this permissive. That means when this contact is NC, this relay is picked up, means all these conditions are met, means all the remote from the remote location, all these switchgear, all the abnormal conditions are monitored, and we switchgear this intelligent system makes sure that there is no abnormal condition in the switchgear, in the local switchgear as well as remote switchgear, and switchgear ready to close. Then immediately it will pick up, and then this circuit is closed, then it will come over here. So local energization or remote energization, both case permissive is required. The permissive will come over here. Then we have already discussed about the interlock for the arc switch and the disconnector that is made. Then the mechanism, spring mechanism, tip coil spring mechanism or any other fault condition is not present in the disconnector switch or in the tripping circuits. That is also ensuring from here disconnector switch. That is also ensuring over here. Emergency push button has not operating. When this condition is made, then the closing coil of the breaker is energized and breaker is closed. Closing coil energized means how it is happening. I am removing this part. How this closing coil actually, you could see the breaker inside. This is a bus bar. From the bus bar there is a bus coming. It is a bent bus bar. It is coming from here. It is a three bus bar about like this. This is a one and this is a third one. Then this is a breaker chamber. Suppose there is a breaker cubicle. In the breaker cubicle there is a bottles. These are the three bottles. This bottle inside. This is a, suppose this is coming inside here, and from here it is coming to the outgoing terminals. It is like this. Second set is that like this. It is coming like this. This is a bottle inside. It could be PCB. It could be SF6 bottle. Inside there is a contact. This is a contact. You can say this is a contact. Normally this contactor, this is a solenoid operating contact. These contacts are operating by solenoid. Means this closing coil is actually a solenoid. Now it has a, you know, solenoid, how this, when the solenoid is picked up, immediately this contact will move here. Immediately this contact will closed and the power will go. The moment closing coil is open, that means this solenoid is de-energized and the contact will move away. So this will, so it is actually inside the bottle this is happening. You cannot see it from outside. These are the SF6 bottle or this vacuum breaker bottle. Inside the bottle this making breaking is taking place. So this making breaking we are using through the closing coil. The closing coil actually it is a solenoid. When it is energized, immediately this contact, this plunger is moved in and this contact made and the power is flowing through here to the circuit. So this way it is working. So with this we can close the breaker. So when we are going to close the breaker, these are the various interlock we need to look into and accordingly this scheme to be developed. Here we have used the various contact picture as per IEC. IEC NO contact we show like this. This is the NO contact. NC contact we show like this. This is a, when you show the NC contact, so this is a NC contact. This is one position. This is another position. This is a, in case of changeover, this is a normal NC contact. This is the NO contact, and this multiple position switch I have represented in this way. This three position means this is one position, this is another position, this is third position, and we are writing this way means this is one position, center one is off position, and this is the arc position. We have to read this. Which position will be selecting? That is from the lever. This is the switch handle we are operating. If I put the switch over here, it is off position. If I put the switch over here, it is off position. If I rotate the switch over here and connect over it is on position. This way, the switch is operating with hand manually operated switch. So these are the closing scheme of the circuit breaker. So this session will be closing over here. In the next session 3, we will be discussing about the tripping circuit of the or off circuit of this circuit breaker, and then we will be proceeding in this way. So I am closing this switch to this session 2 over here, and thank you very much to all of you for going through these sessions. And it is my pleasure that if it benefit to any one of you by any way, that would be my great pleasure. Keep it on. Thank you very much indeed. Thank you.